Okay, this is Mr. Peterson, and we're on page 4 of the note set for Algebra 2, sections 4, 5, and 4, 6. And we are supposed to find, this is a continuation of the other video, we're supposed to show that these two matrices, A and B, are inverses of each other, which means when we multiply them, we should get I. So let's multiply them. We're going to first of all divide the first matrix into rows, and the second matrix into columns. And we get this sort of tic-tac-toe board here, which means we have 9 different calculations to do, and it involves actually more calculations because to get these numbers you have to do a lot. Okay, you go across the top row and down the left-hand column to get this top row left-hand column. So the first product is 8, and then we have -5, which is -13 total. And then we put down another -2, so you get, no, let me do this right here. There's 8 minus 5 would be 3. And then these last ones here give -2, 3. Better write all this down here. You get 8. And then when you do these two, we just did those two, you get -5. And then finally, 2 and 1 multiplied together gives -2. And that will give 1. Okay, the next set you do is going to pick up where we left off. We're going to do the top row again, so we'll use these numbers, but we're switching to the middle column. So the first pair here is -2 times -3.5 is -7. And then after you get that one done, you switch to the next pair of numbers. That gives -5. And finally, hold on here. The first one's +7. Yeah, I did that wrong. And then finally, the next pair here is -2. And that'll give 0. All right, then we switch to the top row. We've been using that one. And we're going to do the right-hand column to find this top row right-hand column. Okay. Where are we here? Okay, -2 times 2 is -4. 1 times 3 is 3. And finally, -1 times -1 is 1. Add those numbers and you get 0. Okay, now this is working out pretty good here. And instead of bogging you down into all the details, I'm going to do 2 more. And then we're going to just fill this in with the result in the interest of time. Okay, we are finally switching to the next row. And if you pick the middle row in the left-hand column, you'll be finding this value. So the first pair we multiply would be 2 times -4. 0 times -5. And finally, 4 times 2. Add those up and you get 0. We'll do one more here, and then I'll fill in the rest here. Okay, so the next set we're going to look at here is we're trying to find the second row and the second column. So we're going to use the second row and the second column over there, and that'll give -7 when you multiply the first pair of numbers. Multiplying the next pair, 0 times -5 gives 0, and I'm writing these in the wrong spot here. And 4 times 2 is 8, and those numbers add up to 1. Now you got to keep this up until you find that you get this matrix, and you'll notice that it has that familiar pattern, 1's down the main diagonal and 0's everywhere else. So yes, these are inverses. A and B are inverses. And you could actually label, instead of labeling the B, you could say A inverse like that, once you know that they are inverses. Or you could cross off this one over here and call it B inverse. They're inverses of each other. Okay. And the way you know that is when you multiply them, you get the identity matrix. This is I over here. It's a 3 by 3 I. Okay. Now, you were given two matrices and asked to show that they were inverses, but now you're going to be given one matrix and asked to find the inverse, and you'll do this on a 2 by 2 matrix by hand. There are ways of doing this stuff on the calculator, but for now you're trying to learn how to do it by hand. Now, this complicated formula here is going to be used. Okay, so what you do on the outside is a fraction. You go 1 over the determinant number. So I call that 1 over the fish number, and I'll draw that right facing fish to remind you of that. So 1 over fish, and you multiply it by this new matrix that you've gotten by modifying this one. And what happens here is on the main diagonal, it used to have A in that corner and D in this corner. And so these two have switched places. So we've got the fishy, and now in this diagonal here, 1 over the fishy, and then switch places. So one more, the A and D swapped locations. So switchy, fishy, switchy. And then in this direction, you're changing the signs, switching the signs. You're flipping the signs, excuse me. So you had C and B, they're not changing locations, they just changed to their opposites. All right, so I'll show you how this works here. You first of all find the determinant, and that would be 6 times 20 minus 125. Let's see, 120 is the first diagonal, and you're subtracting 5 times 25. So this determinant number is negative 5. Okay, so the first thing you do here for the inverse, A inverse, is you go 1 over that fish number. All right, then you take your main diagonal numbers, the 6 and the 20, and you switch places. And in the other direction, you don't switch places, but you go with you switch signs. So negative 25 when it used to say positive 25, and negative 5 when it used to say positive 5. So that direction, you're going to switch the signs. So switch places, switch signs. All right, so 1 over negative 5 times that matrix. And now we're just going to apply scalar multiplication. We're going to multiply everything by negative 1/5, and it'll look like this. Okay, simplify the corners. 20 over negative 5 would be negative 4. The next corner here would be negative 5 over negative 5 would be 1. This corner gives 5. And then you get negative 6/5. So the inverse of A would be negative 4, 1, 5, 6, negative 6/5. And if you multiply this original matrix times this matrix, you should end up with I. And that's what we learned on the previous section. Okay, so we'll pick up on the next part in the next video.